All right, so today we're going to do, this is it 6.2? Yes, 6.2 Law of Cosines. Okay, so really yesterday we looked at 3 cases. We really only looked at 2, but you could look at 3 cases. So let's do this. If you have angle, side, angle, or angle, angle, side, or side, side, angle, okay, then you're going to use law of sines. Remember, we're solving non-right triangles, so you're going to be dependent on the type of information that you're given in order to determine, do I use law of sines or do I use law of cosines? So in these 3 cases, you would use law of sines because you could create those proportions. Okay, you could create those ratios of the side and the angle together. But now you're not always given this type of information. Sometimes you're given different information. So in the case of side angle side or side side side, you're going to use law of cosines. Okay, so now let's say we had this triangle here. Let's just call this A, B, and C. So that would be side A, side C, side B. Remember, it's always across from its angle. Okay, now in this case, let's talk about the law of cosines, which again, these are formulas that you have to memorize. Okay, so this is the law of cosines, and this is really for finding the sides. Okay, so if you're looking for a side, you'd want to use one of these formulas. So you have a squared equals b squared plus c squared minus 2bc times the cosine of a. So that's the case of you're looking for the side A. If you're looking for side B, then you would do a squared plus c squared minus 2ac times the cosine of b. And finally, if you were looking for c squared, you would do a squared plus b squared minus 2 times a times b times the cosine of c. So in this case, you're looking for a side, and you have to be given 2 sides and an angle. So this is like side angle side case. Okay, that's a type of information that you're given. You know what I'm talking about when I say side angle side, right? Like the angle has to be in between the 2 sides, right? Has to be included. So like C, angle B, and A. This would be a side angle side case. Remember that from geometry? Okay. So now that's like the first scenario, right? Is the case of side angle side. So now let's look at formulas if you were given just 3 sides. So when you're given 3 sides, you're going to use this. So I guess let's say, let's do it this way. Law of cosines, and this is when you're looking for an angle. Okay. So now all I'm going to do is actually manipulate these equations, but sometimes students like to have this part and just memorize it because it's easier. Okay. So this is the case of when you're given 3 sides and you're looking for an angle. The cosine of A is equal to b squared plus c squared minus a squared over 2 times b times c. Okay, it's just really manipulating the equations above and solving for the angle. Okay, so the cosine of b would equal a squared plus c squared minus b squared over 2ac. And finally, the cosine of c is going to equal a squared plus b squared minus c squared over 2ab. Okay, now you have to memorize at least one of these formulas for the law of side, like finding the sides, right? Because you can manipulate it into all the other ones. It might be easier for you to memorize one of each, and then you'll know how to manipulate them. It's your choice, okay? So here's the thing. There's 2 rules really to follow, okay? So these are kind of like a side note. When you're solving, you always want to find the largest angle first, okay? So try to obtain the largest angle first. The reason why you want to do that is because it kind of knocks out the possibility of getting the ambiguous case, okay? So we don't worry about the ambiguous case if we follow these rules for law of cosines. The other thing is like, let's say that's not possible, then the second rule to follow would be if you start with the law of cosines, you finish with the law of cosines. Okay, so as a rule, it's like if you're going to use law of cosines, just use it all the way through. Don't mix in some law of sines too. Okay, you see what I'm saying? Because again, it rules out the ambiguous case, so you don't have to worry about that now. Okay, sound good? Okay, so are we ready to try a couple examples? Sure. Okay, so again, you're going to have to memorize these formulas. So far you have the law of sines, the area formula for, given two sides at an angle, and then the law of cosines. All right? Okay, example 1. Solve the triangle. Given A equals 14, B equals 11, and C equals 21. Okay, so the first thing we should do is draw a picture. So just draw a triangle and then kind of label it how it looks. So this to me looks like along the side, so that's C. I don't know, these are pretty close. I'm going to call this A and this B. Okay, so this is 14 and this is 11. Just gives you a better idea of what you're looking for. Okay, so everybody agree that this is a case where I'm looking for, if I have to solve the triangle, I have to find all the angles and all the sides, but I've been given all the sides, so all I have to do is find angles here, right? So I'm looking for angle A, angle B, and angle C. So I'm definitely going to have to use the law of cosines. I'm going to have to use it to find angles. Okay? Everybody see that law of sines is not an option here. Okay? All right, so let's start. We're going to find the largest angle first, which means we're going to find angle C first. So the cosine of C equals what? A squared plus B squared minus C squared over 2 times A times B. Okay. Now, when you put this in the calculator, you can do this all in one step. When you type it in, you're going to do the inverse of cosine. You're going to get that big set of parentheses, and then you're going to put a parenthesis set around the numerator. And, whoopsie, not there, here. And you're going to put a parenthesis set around the denominator. And then you're going to close the big set. Okay, so everyone try right now to put this in the calculator, because sometimes students can set up the whole thing right and then they screw up on the calculator entry. This little guy here. Okay, you should be getting angle C is 113 point, is it 7.4? Okay. And it's 740? Okay, so now we know that angle. Does anyone need help entering in the calculator? I can show you mine. Yeah, I can. Sure? Okay, so again, we want to make sure that we're, oh, you don't really need to sound with this calculator. Okay, so again, you want to make sure you're in degree mode. Okay, then we're going to put in second cosine. There's my big set of parentheses. So now I need another set around the numerator. So I have 14 squared plus 11 squared minus 21 squared. close that set, divide by 2 times 14 times 11, close that set, and then close the entire set around the cosine. Okay, so the parentheses are kind of key there. You got to be careful with those. All right. Okay, so now that we've done that, now we got to keep moving, right? So we have one angle, still can't find the other two without using the law of cosines. So now let's just go to the next largest angle. So let's find A next. So we're going to do the same thing. The cosine of A equals, let's see, we're going to do 11 squared plus 21 squared minus 14 squared. So you do the two sides next to the angle, right, squared added together, then you subtract its side squared divided by 2 times those two adjacent sides. All right, again, make sure you have your parentheses in the right place, make sure you're using the inverse. This time I got 37.608 degrees. Let's make sure I can get some verification there. Did you get that? Okay, good. Okay, so now the good news is we have two angles. So if we have two angles, we know that there's 180 degrees in the triangle. To find the measure of angle B, can I just subtract them from 180? Right? So I don't have to do law of cosines again. So I'm just going to subtract the two angles that I found. And I'm going to get 28.652 degrees. And again, please put like a box around your answers so that they're easy for me to find. Okay? Any questions? Yes? Yes, for this whole chapter. Yep, not going to have to worry about switching degrees. Okay? Degree and radian, I mean. Okay, so the next formula is another area formula. Okay? So this is called Heron's formula. Okay, so this is to find the area of a triangle given only its three sides, which we're going to call A, B, and C. Okay, so let's do an example of it. Well, actually, you need the formula first, right? Okay, so this is what it looks like. Area equals the square root of S times S minus A times S minus B times S minus C. So we know what A, B, and C are, right? Those are the side lengths of the triangle. What you don't know is S. So S is the semi-perimeter. What do you think that means? One half of all the sides added together, right? Half of the perimeter. So to find S, all you have to do is add A, B, and C together and divide it by 2. Okay? So it's pretty simple. But again, this is another formula that you have to make sure you have memorized because I will not be giving this to you. Yeah? Heron's, H-E-R-O-N. Okay, so let's do an example of this. I guess we'll just call this example 2. Find the area of the triangle. Given A equals 14, we'll just use the same side lengths. B equals 11 and C equals 21. So now we're going to find the area of the triangle above. Okay? So the first thing you have to do is what? Find S, right? So find the semi-perimeter. So we have 14 plus 11 plus 12 all divided by 2. So 46 divided by 2. Thank you so much. Not 12, 21. Thank you. So we get 46 divided by 2. So S is 23. And now we just have to plug it in. So I'm going to have the area equals the square root of 23 times 14 minus, I'm sorry, it's S minus A, not A minus S. 23 minus 14 times 23 minus 11 times 23 minus 21. Okay, so you can plug this into the calculator as is right now, okay? Or you could do the subtraction and it would be a smaller piece to plug in. It's your choice. I would just plug it in as is so you didn't make any mistakes with your subtraction. So you're going to do the square root, and then you're going to just type it in how you wrote it. Make sure that it's all under the root. You should get 70.484. And again, let's just write units squared, so that way when we do see some units, we make sure that we know that they're squared units. Questions? Pretty easy?